Welcome to MyProjectBazaar.com. Now we discuss about the product for all digital energy sensing for minimum energy tracking. Next we see the abstract for the product. The whole class of system such as the wireless sensor systems for remote monitoring and implantable medical electronic devices and so on has been made possible by ultra low power very large scale integration circuits. These systems are often several constraints in size and the battery supplying energy will therefore be limited capacity since it's often inconvenient or infeasible to replace the battery. It's the permanent to minimize the not energy consumed by the system to maximize its lifetime. The energy consumption of the system can be reduced by lowering the supply voltage. However, at very low supply voltage, the leakage energy distance and the net energy consumed per operation starts to increase. The minimum energy point depends on the activity of factor and also sensitive to produce the temperature variations, and therefore the location of the map change during circuit operation. To track the map, it's necessary to sense the energy consumed per operation at difficult supply voltages. Minimizing energy consumption is utmost importance in energy starved system with relaxed performance requirement. This brief presents a digital energy sensing method that requires neither a constant voltage reference or time reference. An energy minimizing loop uses this to find the minimum energy point and sets the supply voltage between the minimum energy tracking technique in our process. In this paper, we present a digital energy sensing that does not require any sort of reference, is robust to process variation and performance well over the wide range system current consumption. Nowadays, communication industry field is mainly focused by the high data transfer and the more channel capacity in mobile communications. FAR filter architecture is used to effectively remove the noise and receive the channel data bits and reduce the less circuit complexity. Next, we see the flow diagram for the product. First, we apply the input data signal data bits and clock signal for controlled purpose for overall FAR filter architecture. Then to develop the troop detection circuit functional block. This troop detection circuit functional block is used to identify the minimum energy tracking for overall architecture process and to activate the clock based counter operations at the same periodic pulse samples for overall architecture. These clock periodic samples to create the enable signal and the data passing to the digital controller unit. The D register architecture to inbuild present to the based on the enable signal to data passing for overall FAR filter architecture. This data passing to passed from D register functional clock pulses based architecture then to passing the shifting operation for with the same periodic pulse levels. Each and every time we update the troop detection circuit for overall architecture based process and to get the enable line for every periodic samples and to passing the coefficient data based multiplier architecture for overall 32 tap FAR filter architecture. So we apply the 32 coefficient signal for 32 tap FAR filter architecture and to passing the data passed in the accumulating unit. The tree based accumulation unit to consist of the more number of adder element for every accumulation process. This accumulation process mainly based on the carry generation time and to reduce the overall circuit complexity for multiplier and the adder circuit. The multiplier based development we use the Vedic based architecture for overall architecture process, and the tree based data accumulation unit is used in the adder architecture carry look ahead adder architecture for overall addition process. These two kind of process to reduce the overall circuit complexity and the troop detection process to reduce the power consumption for overall FAR filter architecture. This is how the flow diagram for minimum energy tracking sensing architecture. Finally, we see the output for the product. This is the critical filter architecture for overall Xilinx IC project. You just double click the critical filter file and to open the software. This to select the simulation oriented process. Then to select the troop detection circuit based 32-tap FR filter architecture. Then simulate behavior model. This is the simulate model to simulate the overall architecture for our required output based process. Then to apply the input data signal and the clocking enable signal for troop detection and based 32-tap FR filter functionality. These are the final output functions. Then we go to we apply already the coefficient signals and we apply the clock one by one data passing to the overall architecture. Then reset equal to 1 and to apply the clocking signal for then to remove the reset signal and to passing the data shifting operation for overall 32-tap FR filter architecture. Then to update the every clocking signal for enabling purpose and to passing the overall shifting operation for if complete the 32-tap FR filter architecture, and finally we get it to the final output for overall FR filter functions. These are the minimum energy tracking deductions for our required enabling signals. These signals mainly based on the counting based enable architecture for overall inverse FR filter functions. These are the simulation diagram for required 32-tap FR filter for minimum energy tracking operations. Then we go to the implementation oriented process. The implementation oriented process, we select the troop detection circuit and we analyze the RTL and technological diagram for required architecture based process. RTL diagram based representation, we represents the what are the program to be present in the logical diagram representation for troop detections FR filter architecture. Then we go to the technological diagram representation for our overall architecture. Then we go to the synthesis report and design summary analysis for required device utilization summary for required how many lookup tables, flip-flop and input output presentation for overall architecture. Then we go to the timing summary analysis for required output architecture. This is the overall path delay time and the latency time and the clock speed level and minimum period level for overall 32-tap FR filter architecture. This is the final output for our FR filter architecture.